Today's lesson is on parallel lines and proportional parts. First, we will look at what happens when a segment in a triangle is parallel to one side. Our theorem states if a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, then it separates these sides into segments of proportional length. So here I have a triangle ACE. I have a segment BD that is parallel to AE, so I have a segment parallel to one side. And what I can tell from that is the parts are proportional. Or, if I label them with individual variables, P, Q, R, and S, I can tell that P to Q, the two pieces on one side, are proportional to R to S, the two pieces on the other side. Now, how do we use this? Well, here we have our triangle. We know that HL is parallel to EF. We know that EH is 9. We know that HG is 21. We know that FL is 6. And we are searching for LG, so I'll call that X. According to this theorem, because the lines are parallel, the sides are divided proportionally. That means I can set it up. 9 over 21, the two parts on one side of the triangle, equal 6 to X, which are the two parts of the other side of the triangle. Do our cross products. 9X equals 126. Divide by 9, and X equals 14. Now, some of you may have wanted to set it up a different way. Because these parts are proportional, and because the parts of properties of proportions, we could also match across the sides of the triangle like this. So I could have said 9 to 6 equals 21 to X. Notice when we do this, we get the same cross products. 9X equals 126, or X equals 14. Both are good, acceptable methods of doing it. Now, I'd like you to try the next problem on your own. Pause the podcast, then come back and check your work. Notice again, it doesn't matter whether we match up the parts on one side and compare them to the parts on the other side, or match them up across the sides of the triangle. We still get 13.5 for X. Our next theorem takes the first one and works it backwards. In this one, we know the sides are proportional, and from that we determine that the segment is parallel. So, for example, on this, because 5 to 3 equals 10 to 6, our cross products say 30 equals 30. Therefore, I know that these two triangles would have been similar, which means this line is going to be parallel to that third side. Now, let's take an example. We're trying to show or determine, is the line parallel? So we just write in our pieces. I know that I have the whole side of HM is 15. I know that from H to N is 10. Hopefully we could figure out how long NM is. If the whole thing is 15 and part of it's 10, the remaining part has to be 5. And on the other side, it just tells me that HJ is twice the length of JK. So I'm going to call JK X, which means HJ is 2X. So I have 2X and X. What I need to determine is, are those sides proportional? Notice again, the third side in this case would have been 3X. Let's try it out. 10 to 5 equals 2X to X. We could do our cross products and get 10X equals 10X. It's the same on both sides. So check, and yes, they are parallel. We have one more theorem today, and this theorem says that the mid-segment of a triangle is parallel to one side of the triangle and equals 1/2 of the parallel side. Now, here's a problem. We have not defined mid-segment, so we need that. A mid-segment joins the midpoints of two sides of a triangle, or even on a trapezoid, it's the same thing. It would join two sides of a trapezoid. Now, if it's joining the midpoints, this is my mid segment, it's joining midpoints, we need to stop and think about what a midpoint is and what it does to the two pieces of the side. That's right, the midpoint does cut a side into two equal parts. So on my left side of my triangle I have two equal parts. On the right side of my triangle I also have two equal parts, but they don't have to be equal to each other. Now, if this is true, then basically this is what it's saying. If this piece is 2, this piece is 2, this piece is 3, and this piece is 3. What this theorem is telling me is that if I know this bottom side of the small triangle is 5, then the bottom side of the large triangle is going to be twice that. It's going to be 2 times 5, which is 10. That's all we really need to know about that. It also tells us that the other side is parallel. So I know that these are parallel lines, and I know that this side is 10 and the other side is 5. Or the mid segment is half of the side it's parallel to. Now here's a problem. We're going to try it. It has lots of good stuff in it. We have some coordinate geometry, which means we're going to have some formulas we follow, and some other good stuff. So let's start with graphing the triangle on the coordinate plane. With this problem, I would like you to attempt each step of the problem before you check your work against mine on the podcast. So pause the podcast and do part A, draw the triangle on the coordinate plane. The triangle is on the coordinate plane. Now it says DE is a mid-segment. Well, there are three. The mid-segment could either be parallel to AC, AB, or BC. Because in our problem we want our mid-segment parallel to AC, that means I need to find the midpoint of segment BC and the midpoint of segment AB. Pause your video. Find your midpoints. Don't forget the midpoint formula. Add the x values and average, add the y values and average. When I calculated the midpoint of AB, I came up with the point 2, 0. I'm going to call that point D. Now I need to still calculate the value of the midpoint of BC. Pause the recording and do that if you have not already finished it. I calculated the midpoint of BC at 3, 4. I'm going to label that point E and draw the segment. Now I need to verify that the lines are parallel. Remember what parallel lines are. They have, that's right, the same slope. So let's find the slope of AC and the slope of DE. For the slope of AC, I'm going to have to do the difference of the y's over the difference of the x's. So that's going to be 9 minus 1 over negative 2 minus negative 4, which is 8 over 2, which is 4. Now I also need to do the slope of DE. And when I do the slope of DE, I have 4 minus 0 over 3 minus 2, which is 4, over 1, which is 4. We can see that the slopes are the same, therefore our lines are parallel. Now we have one more thing we have to do, which is to verify that DE equals half of AC. This means I need to know how long each of those segments is, which means I need my friend, the distance formula. So go ahead and do your distance formula for DE, your distance formula for AC, and then compare your answers to my work. Notice that AC was 2 square roots of 17 after I simplified the square root, and DE was simply the square root of 17. So DE was 1/2 of AC. We now have 2 corollaries which go along with this, and the corollaries say that if 3 or more lines intersect 2 transversals, then they cut off the transversals proportionally. Now, how are these actually connected to the first problems? Well, if you were to extend the 2 lines, notice that at some place they're actually going to form triangles. So that's how they're connected. Now, if we take these pieces and set them up this way, basically what this theorem is telling me is that the ratio of A to B equals the ratio of C to D, or if you choose to match up going across the figure instead of along the same lines, you could also say that A to C equals B to D. This is going to allow us to solve some problems. For example, suppose that A is 4, B is 1.5, C is 10, and we want to know what D is. Well, D would just be D or X, whatever variable you choose. You can simply set it up as 4 to 1.5 equals 10. I'm going to use D. 10 to D. So 4D equals 15, and D would equal 3.75. The next corollary says that if the segments on one side are congruent, then the segments on the other side will also be congruent. So this again goes directly from the one before it. Let's go ahead and set it up. Because the first set of sides are marked as congruent, you can see the markings on the diagram already, we know that 3x minus 4 equals 6 minus 2x. Well, we can solve this. That would be 5x minus 4 equals 6. 5x equals 10. So x equals 2. That gives us the value for x, but it doesn't tell us how long the sides are. We could substitute that in. 3 times 2 minus 4 is 6 minus 4. This piece is 2. If these don't work out to the same thing, we know we made a mistake. When you substitute in 2 for x in the second one, we have 6 minus 4, which is 2. So that worked out well. Now, what this theorem tells us is because the ones on the left transversal are congruent, then that means the ones on the right transversal are congruent as well. So I also have 5/3 y plus 1 equals 3y. Now, to complete solving for y, the first thing I'm going to do is eliminate the fraction. And to eliminate the fraction, I'm going to multiply both sides of the equation by the denominator, which is 3. I know that multiplying by 3 will eliminate the denominator on the 5y over 3, so I have 5y, and when I distribute it through, I get 3. So I have 5y plus 3 equals 9y. Solving the equation, 3 will equal 4y by subtracting 5y on both sides. So y is going to equal 3/4. Now, again, these sides should end up equal. So let's see what happens when I sub in 3/4. The one in the denominator is going to be a little bit easier. 3 times 3/4 is 9/4. The numerator is a little bit tougher. The 3's will cancel. So I have 5/4 plus 1, and 1 is 4/4. So 5/4 plus 4/4 is 9/4. So the two sides did end up congruent. This concludes today's podcast.